Good evening, everybody. CJ here, your local friendly technology addict, and you're watching the Tech Addict's Attic. So I've tried doing this video probably about 10 or 15 times today. Um, you know, we it's been a busy couple of days. We've had a sickness going around the house, and it's affecting all of us. But fortunately, I've got a pretty strong immune system, so I'm able to truck on. But I can tell that it's affecting me because I'm one of those, when I get sick, I get irritable, and a whole lot of things. It's funny. It's almost like there's a little demon sitting on my shoulder, keeps picking and flicking my ear or something. Just trying to tick me off. But you know what? It's not going to work because I'm doing this, and I want to be done. So. First video I took, I went through a whole bunch of stuff, and then I did another video that explained a project that I've been working on that it all ties in with. Between the two, it wound up being a complete garbage because of a technical issue that I had. Wound up getting a whole lot of static on it. So I'm going to try to combine everything into one video, and I'm going to be talking kind of fast, so hope you all can keep up. But it is what it is. So a few of you, and myself included, have noticed that my audio volume on YouTube has been kind of diminutive. And I'm already finding that I have to just about yell. I'm not yelling, but I'm being pretty loud. And I want to stop that. I want to be able to talk in a normal, conversational tone, as though you're sitting right here with me. I don't like yelling. Contrary to popular belief, I'm always loud because no one ever hears me, even on YouTube. You can't hear. So I'm yelling all the time. So I'm going to try to fix that with an amplified microphone. I was already working on this for a different project, though, and I decided that I'm going to make two of them and just tie one into my phone. But you all may remember from a video I did about 1.5 years, 2 years ago, this telegraph key. I bought it at an antiques market, and it's nothing more than a momentary contact, single pole, single throw switch. Closed, open. Ties in with an oscillator. You go da 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 da, and you're putting Morse code out on the airwaves. Great. You all know I'm an amateur radio operator. I've had my CW portion of the code of the license. You can tell it's getting late. So I started out with a no-code tech license. Within a year or two, I upgraded to the code tech. And then a little while after that, I kind of, things happened. Life, college, work, stuff like that. I finally decided to get back into it, upgraded my license, got some extra privileges. And now I want to make use of those privileges, so I need to become proficient in Morse code again, because that is one of the things that I want to do, is do some QRP on HF. If you don't know what it is, you don't need to worry about it. But basically, I want to do some Morse code. So I need to become more proficient with Morse code, and I decided to make a code practice oscillator. And so I'm sitting here breadboarding it, right? And I probably should have just tied in a couple of transistors in a feedback loop and made an oscillator that way. That would have been a more clean, that would have been more like a clean sine wave. But instead I'm dealing with a 555 timer in astable or multi-vibrator mode, so that it's sitting here constantly back and forth. And I'm getting about a 50%-ish square wave out of it. Which, of course, you don't want to put that on the airwaves. I want something that I can put on the airwaves without having any issue about quality of tone. So I needed to convert that square wave into more of a sine wave. I got a little filter network on here, a couple of resistors and capacitors, and I've got a pretty close to sine wave approximate. It's not perfect, but orally, it'll work. It'll be just fine. So the reason I'm using a 555 timer is because a couple years ago, when I was buying electronic stuff, I bought 50 of these things on eBay. Now I've got to find a use for them. Hey, I got a great deal. It was only like $5 for the lot, right? But it is what it is. They're not even genuine article. They're labeled like a Texas Instruments, but the logo is crap. It's like really bad print quality. It's definitely a knockoff. But I digress. So I'm making a use for them in this, and it just happens to fit in an Altoids 10. Now, I hate these little snaps because what happens is you have no strain relief here, and even though they make contact, they wind up failing over time because of fatigue with the wire. So I'm probably going to replace this with a little barrel jack for DC input that I'm going to have mounted to the inside or to the side of the Altoid 10. And then, of course, I got to figure out how I'm going to put the knob on the lid, probably up in the top left corner. I think the knob was frequency control, and then I've got a little trimmer pot down here for duty cycle, which you can tell with the ear when the duty cycle's right. You don't even need an oscilloscope for that. But basically, the idea was to mount the code practice oscillator on the telegraph keyboard. Okay, great, that's fine. Then I got to thinking, you know what? If I'm going to be tying this into an HF rig, not all of my HF contacts are going to be using Morse code. Sometimes I'm going to want to use voice. So I'm going to need a way to take a microphone input, modulate that into the transceiver. So the idea was that one of my coworkers or end users or something was throwing away a set of computer microphone and headset. Little cheap $5 things that, you know, they're garbage. They break within a month. Wires break in them or whatever. But, you know, the speakers themselves that are in the headset are still good. It's just a matter of mounting the wires on them better. The microphones definitely are still good. There's nothing wrong with that. And the fact that it was getting thrown away doesn't matter to me. I hate seeing technology being disposed when it's still useful. It still has useful life in it. I bought from Radio Shack some 10, 15, 20 years ago this Electret microphone. And it's the only one I've got. So if I made a project with this microphone, I've got to find some way of making it look less ugly. Whereas with this microphone, it's already prefabricated. I just have to have a mount for it. And so for the purpose of this project, I mounted it to a chewing gum canister, but I'm eventually going to have it mounted to the side of the Altoid 10. The only problem is getting this little white dot here lined up properly, because that little white dot is where the opening is for the microphone. On the back side, you've got solder points. So this is where you got to be talking into if you want it to pick you up. No big deal. It's just one of those caveats you got to watch out for. I'll probably just mount it on the right-hand side and have the power come out the left or out the back or something. I'll cross that bridge when I get there. But that was the project that this microphone was going for. But I figure I can go ahead and use that same schematic, that same amplifier, to get you guys to be able to hear me. Now, if you get into electronics experimentation, you always have to have a notebook. This is my random scribbles book. I don't care if anything happens to this, because anything worth keeping, I transfer over to another notebook that I keep for the ideas and the schematics that actually work well enough. I might implement them in a future, more serious project. But this is mainly just me playing around kind of stuff, like what I'm doing here. Metal detectors, for instance. Function generators, code practice oscillators. Here's a schematic for a 40-meter sideband transceiver that I found on the internet, and it looks basic enough I might be able to build it one day. There are a few things that I'm going to have to purchase or source somehow, a couple of crystals that I don't have, transistors I don't have, but you know, it looks simple enough I might even be able to breadboard it. I'm really interested in trying this stuff. But anyway, long story short, I've got several pages here on a microphone amplifier which follow several pages of a code practice oscillator. So between the two of them, once I get my microphone amplifier really hammered in and I know that I like it, I know it'll work, I know that it's good to go, then I'm going to take that schematic and I'm going to combine it with my other schematic, put them both together in that other notebook, because that's going to become part of the input section of an HF rig whenever I get around to building it. Everybody's got a bucket list. One of the items on my bucket list is building an HF rig and making a contact somebody who's in another state or even another country using something that I've built right here with my own two hands. Well, granted, using manufactured components like resistors and whatnot. I'm not going to build those by myself. Alright, so I know you can't see it, so I'm just going to describe it real quick. Like, what we have here is failure to communicate. We have 3 stages. They're all 3 identical in every regard except this one resistor on the very end. The emitter of the 3rd stage is about a little bit less than half the value of the emitters of the other stages. So we have your signal source. In this case, I was using a function generator, and I had that going into a coupling capacitor, and that coupling capacitor went to the base of the 1st stage. Now, that's where I connect my microphone. More on that in a moment. That base of the 1st stage has 100 k ohm to the VCC, which currently is 9 volts, and a 10 k ohm to ground. From the base to the collector, we have a 1 meg ohm. From the collector to VCC, we have a 27 k ohm. And from the emitter to ground, we have a 3.9 k ohm. The output at the collector has another coupling capacitor to run into the base of the 2nd stage. Of course, the 2nd stage is identical to the 1st stage. And again, we have another coupling capacitor to the 3rd stage. Again, identical to the first 2 stages, except for that last resistor on the emitter. And of course, the collector has an output going through a coupling capacitor. All 4 of my coupling capacitors are 0.22 microfarad or 220 nanofarad ceramic, mylar, whatever these are. You all know the kind. They're the tan ones. Monolithic multi-layer ceramic chip. These things. Alright. Capacitors. But, you know, as you know, there are so many different kinds of capacitors. I mean, you got electrolytics and whatnot. And then you got, you know, even in the ceramics, you've got different kinds. And then you got the special kinds that you can put on line voltage. A whole bunch of stuff that I don't even need to care about. So that's the basic schematic. There's nothing really special about it. It's 3 transistors, one after the other. Now, here's the thing. I'm still kind of elevating my voice just so you guys can hear me. Time to quit that. Now, I'm going to plug this in, but one of the technical problems that I was having is when I plug this in, I've got to use these cheapy little Y adapters that go from a TRRS to 2 TRSs that split it between microphone and headphone. All right? And I prefer, frankly, I prefer this kind of, you know, separate microphone and headphone because not every headphone set has a microphone built into it. Not every headphone set has a 2-ring plus sleeve connector. But the problem is that that connector into my phone is staticky as hell. So I'm going to try to keep the connections clean. This worked on the last take of the video, but then I had an interruption that, of course, any of you who have followed me for a while know that I try to do my videos in one take. I'm going to go ahead and plug this microphone in. There's no amplification other than what the phone itself provides. Alright, and I would like you to tell me, because I'm still talking at the same volume, I'd like you to tell me which one you like better, this one or my phone, at this volume. Now I'm looking at the phone, but the microphone's over here. Now if I'm talking directly into the microphone, and mind you, this thing is about 6 inches away from my mouth, maybe 7 in some cases, and for those of you who live anywhere else in the world, 17 centimeters from my mouth. And me talking directly into it at the same volume, this is me. However, I would much prefer to be talking in a conversational tone, as though you're sitting at the table with me. You could be sitting 3 feet away from me. 3 feet, that's 90 centimeters. Nearly a meter away from me, okay? You could be sitting at the same table. I would prefer to be having a conversational tone. I would prefer not to be yelling at you. It would be really nice if I could whisper so that nobody could hear me,
Although that would involve me having to be right up against the microphone, of course. And that's just not going to happen because I can't do a video this way. So here we are. And I don't know if you can see the oscilloscope, but I'm going to get on that in a moment. So I'm going to go ahead and swap this microphone out with my amplified microphone. Once again, I'm going to make sure my connections are nice and clean so that I don't have any issues with static. Alright, so now, this is me again at the same volume, but you'll notice that this microphone, as long as I don't drop my ruler, this microphone is over a foot away. We're probably talking 45, maybe 50 centimeters away from my mouth right now. Arm's length, right? And I'm still talking at my elevated volume. I'm still kind of, sort of yelling, although okay, you know what? This is my conversational tone. I'm talking to you. I'm not yelling at you. This is just, you're sitting at the table with me. The microphone is this far away, and I know that it's picking me up, but not that great. Now, if you look at the oscilloscope, this is the input fed right off of the first stage input from this microphone. So this is what the first stage sees. I'm going to go ahead and activate the output of the entire circuit coming off of the collector of the third stage. Now, there doesn't seem to be that much of a difference. Okay, so let's try this. I'm going to bring this up a little closer to me. All right, now I'm talking at the same volume into the microphone. Yep, there's my little white dot. And I'm going to bring channel 1 back up. And yeah, they look pretty much the same. Which is funny because earlier I was actually able to tell that test 1 2, test 1 2, test 1 2. Interesting. Earlier I was able to see that the circuit absolutely was amplifying. So now I wonder if you can even hear me, because it doesn't appear that it's even working now. They're both 50 millivolt per division. Interesting. Let me of course you're getting all that static, aren't you? I wonder if you'll pick up the AM radio station when I plug this in here. I don't know. I'll find out in the playback. But let me know. Do you like this microphone? Assuming that it's even working. Because really, I can get right up on top of it, and I can really whisper if the amplifier is actually working, and you could hear every word. So let me know. Let me know if you like this microphone, because I mean, I'll figure something out. If it needs more amplification, I can add more stages. That's not an issue. I may need to add more voltage, but we'll get there. We'll figure something out. And if you prefer this one, and also the audio quality, because as I recall, this desk mic that I've got here was kind of muffled when I heard it on the playback. So this one was nice, crisp, and clear, even clearer than what came with the phone. I really like this mic myself, at least in the playback. But let me know. I mean, because I really, really want to get out of the habit of yelling at my phone when I'm doing a video. So if you can hear me fine right now, let me know that too. Let me know if I need to continue yelling. Let me know if I need to just not even worry about this because it's really no better than the phone itself. You tell me. What do you think? So leave it down in the comments, and I'll check up on those in a day or two or three. See what you all are saying. I'm probably still going to go ahead and build this into my Code Practice Oscillator because it's still useful. The question is, will I be building a second one for the phone? So let me know in the comments, and I'll check up on them. Until then, I'm CJ, and this has been the Tech Addict's Attic. Have a great one.